Now here's an interesting picture, interesting story here. Go ahead, you're getting ready to say something.
I know you guys like brain.
After he left office, he was diagnosed with what? Anybody know? Alzheimer's.
Yeah.
And he eventually took his life, Alzheimer's disease. Here's his wife, Nancy Reagan. Obviously. Well, there's the name there. Okay, 40th president. You guys don't remember when he was in office. He was elected in 1980.
88.
What?
1980 to 1988. 2 terms.
2 terms, yeah. Okay, I want to see what kind of history you paid attention to in U.S. history. Did you learn about him in U.S. history?
Heck yeah.
Oh, yeah.
Okay, conservative or liberal?
Conservative.
Like the poster person for conservatism. Conservatism. Okay? He's like the classic, this is like those on the conservative end of the political spectrum. He's like the standard, the model, okay, of conservative thought. So, probably not a very difficult question to figure out the answer to. Pro-life or pro-choice?
Pro-life.
Okay. Would he have been in favor of embryonic stem cell research? No. Because you have to destroy a blastocyst embryo to get the stem cells, right? Now what's interesting is his wife was, right with him in his thinking. But after he died, she became, believe it or not, an advocate for embryonic stem cell research.
The more you know.
Why do you suppose she became an advocate, a voice for? Guys?
And it could have saved, right?
It could have saved him. Maybe. Yeah. It's interesting when it hits home. It's you kind of know what you think in terms of bioethical issues until you're actually kind of forced in the situation. Here's another example of that, I think. Oh, I just saw him on TV last week. Senator Orrin Hatch, Republican from Utah. Oh, I don't know if any of you have been following the Kavanaugh hearing. Have you been seeing any of that in the news? Okay, he was one of the prime spokespersons during those hearings, and ultra-conservative, okay? Ultra-conservative, but now this is like in 2006, he was holding this press conference on the pros and cons of embryonic stem cell research, and let me give you a quote that came from him from this press conference. Okay, here it is. I'm going to read it because it's kind of fine print. I don't know if you can see it in the back. I do not question that an embryo is a living cell, Hatch said in a speech on the Senate floor, but I do not believe that a frozen embryo in a fertility clinic freezer constitutes human life. That's kind of interesting.
Wow.
And I believe that being pro-life involves helping the living. And that's interesting. It's kind of unexpected coming from him.
I agree.
Isn't it? Well, just so happens he has a granddaughter with diabetes. So, you see, when it hits you where you live, it can kind of influence your opinion. See what I mean? Oh, he's dead now. Actually, that's not funny, is it? But anyway, no. Christopher Reeve, he played in the first Superman movie. He was Superman in the very first Superman movie. What's that?
The original.
In the original movie, the first movie. There's been several, I guess, right? Isn't there another one coming out? I thought I heard.
Maybe Justice League 2? No, you quit that.
I don't know. I heard there's another one coming out. But he ended up paralyzed from the neck down because his horse threw him. He went over, his horse stopped abruptly. He went over the top of his horse, landed wrong, broke his neck, ended up paralyzed from the neck down. So, he became an advocate for embryonic stem cell research, even testifying before Congress. Now, he thought, I remember him saying something like, I saw him on TV once, and I remember he said something like, it may not help me, but at least in the future, maybe they can work out some details, these researchers, to help people in the future who have spinal cord injuries like I have. You know, whip up those spinal cord cells in the lab, get those embryonic stem cells to differentiate into spinal cord cells, transplant them back into the patient's damaged spinal cord. Maybe they would knit together, heal the spinal cord, and help them. Yeah.
A few days ago, I read about they have successfully done spinal cord transplants. I don't know if it was like that day or whatever, but
Yeah, they're having some success with that. Real success.
A world where paralyzation is curable.
What's that?
A world where paralyzation is curable.
That would be pretty awesome. Pretty awesome. All right. So if we're talking about doing something like that, we're getting into a topic here called therapeutic cloning. Take a peek over at page number 17. There we go. Therapeutic cloning. Now this is kind of a marriage between, we're going to take cloning, what you know about cloning, put it together with embryonic stem cells. What do you get? Therapeutic cloning. Want to see how it works? Okay, here's the recipe. Step by step. Here's the recipe in a diagram form. Okay, this is Christopher Reeve. That's the guy who played in the first Superman movie, right there. He's in a wheelchair. He has this little device that he would blow on it and make the wheelchair go this way and that. And can you imagine what that would be like to suddenly be paralyzed from here down? Now, he died a few years after that. He's not around anymore. But this is how therapeutic cloning could have theoretically worked with somebody like that. Okay, here's how it works. There's the recipe. There's the little list recipe. Okay, first you clone the patient. You clone the patient. So we take maybe a skin cell. Can you see this in the back okay? Cole, you're like the farthest away. Gabby, you're like the farthest away. Can you see this okay?
I don't have my glasses on.
Can't see anything? Why don't you come
I'm fine. I'm used to it.
over? I want you to be able to see it. Oh yeah, Lauren's not here. I thought everybody was here. Guess not. Okay. First step. We clone the patient. Oh, that's another one. That's a good thing we're videotaping the lecture. Okay, clone the patient. Now in this example here, they're taking a skin cell. Okay, there's the skin cell. There's a recipe in that nucleus of that skin cell, right? A recipe for what? Him. For him. Recipe for him. We take an egg that's been donated by some woman. With a micropipette, we suck out the nucleus. Take the nucleus from his skin cell, put it into the enucleated egg. In a petri dish, get it to develop into a blastocyst embryo. Okay, that's cloning, right? We've just cloned him. This blastocyst is his identical twin as a blastocyst. We're not going to put this blastocyst into the uterus of some surrogate mother. That would be called reproductive cloning. And almost Every single reputable biologist, medical researcher thinks reproductive cloning of humans would be a bad idea. Okay? Because it's not as efficient as making babies the old-fashioned way, for one. And animals that have been cloned, sometimes they have some health problems. And so to clone people on purpose would kind of be unethical in the minds of most people. Okay? So we're not going to put this into a surrogate mother's uterus. Instead, we're going to scrape out the embryonic stem cells, grow them up in petri dishes, give them the right kind of growth factors or proteins to stimulate them to differentiate into spinal cord cells for him, transplant those into his spinal cord. They grow, they do mitosis, they knit together that damaged spinal cord, and eventually he gets up out of the wheelchair and walks. Okay, that's the idea behind therapeutic cloning. That's just one example. Does that make sense? One example. Now normally, what's the biggest problem with organ or tissue transplants?
Rejection.
Yeah, rejection. I know somebody who had a kidney transplant not long ago, and it was the second attempt. The first one failed because his immune system attacked that transplanted kidney. It was like his immune system looked at the new kidney and said, that's a foreign object, and his immune system started attacking the kidney and destroyed it, rejected it. So anytime you want to do an organ transplant, you've got to try to find somebody, a donor, who is closely enough related genetically that the immune system doesn't view that transplanted organ as a foreign object to be gotten rid of. Does that make sense? And even with real close matches, the person receiving that organ transplant has to take all kinds of medicines for the rest of his or her life that suppress the immune system and basically tell the immune system to chill and not attack that transplanted organ. I knew a guy who had a kidney transplant, and he had to take like 12 pills every day, you know, to keep his immune system from rejecting his transplanted kidney. It's a hassle. So why is there no risk of rejection here? It's his spinal cord cells. Well, not his, but his identical twins, right? Because this blastocyst embryo is his identical twin, so they're going to be genetically identical to him. There's zero chance of rejection. Zero.
Have you ever seen The Island?
No, I never saw it.
They would take these, it's kind of like this, like, people could pay for the service, and they would, no one knew about it, but they would clone the person that paid for the service.
Uh-huh.
It'd be an actual living copy of them that could grow within like a few months to adult human. And whenever the person got hurt, needed an organ, got like, maybe was in an accident, they would just kill the person they grew, harvest their organs, whatever was needed, and then give it
Oh
to
my
the
gosh.
person.
Ooh, that's a little dark, isn't it?
Yeah. But
Just,
no one
just
knew,
a little.
no one knew they were killing them.
Oh my gosh.
And they were told that they were going somewhere better before they died.
Oh geez. Wow. You know, several years ago, the preacher at our church asked me if I would do a Sunday night talk, a special Sunday night talk on any topic in bioethics that I wanted to talk about. This was several years ago. So I talked about this therapeutic cloning business. And it was very interesting. I was really surprised by the response. At the end of talking about this kind of stuff right here, I did one of those little surveys, you know, raise your hand if you blah, 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 think this or that. I said, raise your hand if you think that this would be an okay thing to do. And I was really surprised.
See a lot of hands?
The older conservative people said that they thought this would be okay. This would be ethically okay. I was always surprised. And the younger, more progressive thinkers had a problem with it because an embryo is being destroyed. I was shocked. I thought it'd be just the other way around. You know what I mean? And there was this one lady who raised her hand and she said, "I'm not sure how I feel about this. I'm not sure if I think this is right or wrong because," she said, "I believe that human life begins at conception." That's what she said. And she said, conception is the union of a sperm and an egg, right? And I said, yeah. And she said, well, there's no sperm involved in forming that blastocyst embryo, right? So she said, I'm wondering, she says, I don't know, I've got to think about this for a while. If there was no sperm involved, if this is not a conceptus, she said, nah, I'm not really sure what I think about this. Maybe this is okay. She said, let me think about it. Let me get back to you. I thought it was interesting. There's no sperm involved here. But, on the other hand, if you did take this blastocyst and put it into your uterus, 9 months later you could get Superman's identical twin, right?
That could be one.
Stop. Not until another couple of years.
All right, that's therapeutic cloning. Eli?
So could you technically take a skin cell from a woman and then insert the nucleus of that skin cell into the same woman's egg and then insert that egg into the same woman's uterus and create
She could give birth to her identical twin.
that would
Yeah. Theoretically. Yeah. Yeah, that would be really weird, wouldn't it? Yeah. Therapeutic cloning, make sense? Yes. Oh yeah, where they clone they made the little girl.
Yeah, and like at the end I was like, what? It's been her the whole time, kind of.
Yeah, that was interesting. Lots of action in that movie. Huh?
Have you ever seen Get Out?
What?
Have you seen Get Out? Oh my goodness.
Oh, yeah,
That one.
Get out.
It's experience. It's actually the world's #1 award.
Is that right?
Yeah, I beat out Psycho and Dragon.
Huh.
All those.
Oh my God.
Oh.
All right.
It's got 100% on Rotten Tomatoes.
Don't forget where embryonic stem cells come from, okay? We got it? Embryonic stem cells, right there. That inner cell mass in the blastocyst. Okay. You guys are learning so much, I think. Yes, sir.
What if you didn't take all of the embryonic stem cells out?
Ah, what if you just took,
Like half of them.
or how about theoretically taking 1 or 2 out
Leaving the rest.
and leaving that intact? There's some researchers actually working on
Like what if you could have like a healthy baby and
that. Yeah. Okay, just take out a few of those inner cell mass cells and get them to become embryonic stem cells. There's some researchers actually working on that. Without destroying the embryo, there's some researchers working on that, but it's really hard to do.
I can imagine
It's really difficult, quite tedious. If you do it and enter it in the Purdue Science Fair, you'll probably win.
So there's a problem. Okay, so people have a problem with letting it grow, like you clone your cell growing to be like a baby when it'd be a clone, but they also have a problem with killing it. So they think they should just not mess around with that.
Yeah, yeah. Now, I will tell you this. During the George W. Bush administration, when the funds were cut dramatically for embryonic stem cell research, there were researchers in this country who said, but we still want to work with stem cells. So adult stem cell research took off. Actually, during the Bush administration, it took off. Adult stem cells. That's the next topic. We may get interrupted by an announcement, but I intend for that to be the next topic. Isaac?
So I could have heard this wrong, but isn't there like stem cells in the umbilical cord? Is that a thing?
Yeah.
So can you use those?
Yes.
Can we use those?
Yeah. Yeah.
The only problem with that is like they're not as pluripotent.
Right. Adult stem cells, like those, there are adult stem cells in the umbilical cord of a newborn baby. See, they're only called embryonic stem cells when they're back in the blastocyst. Okay? But there are adult stem cells in the umbilical cord of a newborn baby, and unlike embryonic stem cells, they're not pluripotent.
They're like multipotent.
They're multipotent, right, new word, multipotent. They're able to develop into lots of different kinds of cells, but not all cells.
Excuse the interruption, but a quick reminder that when students arrive via buses and student parking tomorrow, they'll be directed to go through the Bronco Plaza to the South Canopy. So tomorrow, entrance and exit to the student lot and the buses will be through the South Canopy, just for tomorrow. Thank you.
All right, before we quit, before the first bell, before the first bell, anybody ever heard of this lady, Dr. Catherine Verfiley?
Can't say I have.
University of Minnesota. The first scientist. You need to know about her. Well, she's not on the test, but you need to know about her, okay? First scientist to ever get adult stem cells to grow in the lab into different kinds of body cells. Let me show you another scientist who's been famous in the world of adult stem cell research. Dr. Elizabeth Gould. Okay? She discovered that new brain cells are actually produced. Yeah, when I was your age, they told us in school you don't make new brain cells. It's not true anymore. Yeah. They're made in the hippocampus, she discovered, which is that portion of the brain right there. Are any of you guys in psychology with Mr. Fitz? Did you learn about the hippocampus?
Oh, yes, we did.
Awesome. Yeah, he is a great guy. He's a good trainer. So she discovered there are adult stem cells in the hippocampus. They make new brain cells. We will, after the next bell, we'll call it quits. But I want to show you one last thing before you leave. These are some of the places in the body where you can find adult stem cells. We already talked about a newborn baby's umbilical cord, but they're only multipotent. They can develop into all different kinds of blood cells, but not all kinds of body cells. But here are some other places where you can find adult stem cells. You don't have to remember all these. I'm just telling you, they're all over the place. Brain, blood, cornea, retina, heart, fat, skin. One of the best sources of adult stem cells is those jars of fat left over after liposuction procedures. Skin, dental, pulp, bone marrow, blood vessels, skeletal muscle, intestines. We will finish this up next time.